Now that you've become familiar with reducing rational expressions to lowest terms, let's walk through some operations. So to review, a rational expression is similar to a fraction except for the numerator and or the denominator contain a polynomial. So the operations you'll work through in this section are multiplication and division, as well as addition and subtraction. So the rules you're familiar with when working with fractions in order to multiply, divide, add, or subtract those fractions, they apply here as well. For instance, to multiply two rational expressions is the same, we can use the same rule as we do when we're multiplying two fractions. So if we take a over b, where either a and or b contain a polynomial, and we can multiply that by c over d, where c or d may contain a polynomial as well, then we get ac over bd. So to add or subtract a rational expression, it's important to look at the denominators of your expressions first. If you have the same denominator in both expressions, all you need to do is add the numerators and put that sum over the common denominator. If your denominators are different, then the first thing to do is to find the lowest common denominator before you move on. So let's try some examples. Our first problem asks us to multiply x squared minus 16 over x squared minus 25 times the rational expression x minus 5 over x minus 4. So when we're multiplying two rational expressions, we find the product of the numerators and we put that over the product of the denominators. So let's do that first. We have x squared minus 16 times x minus 5. So here's our product of our numerators. And this is over the product of our denominators, which is x squared minus 25 times x minus 4. Now we need to reduce to lowest terms. So our first step is let's factor our numerator. The first parentheses here would factor to x minus 4 times x plus 4, and then add in x minus 5. So that's our entire numerator factored here. And then our denominator, we're going to factor what's inside these first parentheses as well, which x squared minus 25 factors to x minus 5 times x plus 5. And then the last part of our denominator is x minus 4. Then we cancel out what's common. X minus 4 cancels and x minus 5 cancels, which leaves us with x plus 4 over x plus 5. So here's our answer for our first problem. Now for division, we're asked to divide 1 over x squared minus 9 and 1 over x minus 3 squared. When we work with division of rational expressions, we're asked to find the product of the first expression and the reciprocal of the second expression, which means that we're going to flip this fraction. So if we write it as 1 over x squared minus 9, we're going to find the product of this first expression and the reciprocal of this, which is x minus 3 squared over 1. And then we're working a multiplication problem, which we need to find the product of the numerators and put that over the product of the denominators. So this is 1 times x minus 3 squared over x squared minus 9 times 1. To reduce this, we need to factor out what's inside our parentheses here. So we'll have x minus 3 times x minus 3, and that is over x squared minus 9 factors to x minus 3 times x plus 3. And our 1s are still there. Now we just cancel what's common, so x minus 3 cancels. And our answer, I'm going to put this up here, is x minus 3 over x plus 3. So here's our answer for our division problem. Now let's move on to addition and subtraction. In this next problem, we're asked to add 5x over 5x plus 2 and 2 over 5x plus 2. The first thing you'll notice about these rational expressions is that their denominators are the same. So we can add our numerators and then put them over the common denominator to get our answer. So this is equal to 5x plus 2. That's the sum of our numerators here. And this is going to go over our common denominator, which is 5x plus 2. And in this case, our numerator and our denominator are the same, so they end up canceling and equaling 1. So there's our answer for our first problem. Now, a subtraction problem here, we have 2x minus 4 over x plus 2 minus x minus 6 over x plus 2. Again, we have the same denominator in both rational expressions, so we can find the difference of our numerators and put it over our common denominator. So we have 2x minus 4 minus x minus 6, and that's over our common denominator of x plus 2. So we just simplify our numerator. We have 2x minus 4, and then this subtraction sign here, we're going to change this to an addition symbol, and this is going to be like adding a negative 1 times our quantity. So we're going to distribute the negative 1 over each term inside our parentheses. So we have negative 1 times x, it's negative x, negative 1 times negative 6, which is positive 6. And this is all over our common denominator of x plus 2. So we simplify our numerator now. We're going to combine like terms. So 2x plus negative x gives us a positive x. And negative 4 plus 6 gives us 2. That's over our denominator of x plus 2. Again, we have the same thing on the top as we do on the bottom. That simplifies to 1. So when you work through addition and subtraction problems of rational expressions that have the same denominator, you're not always going to end up with an answer of 1 like we did here. But as you can see, this is the simple process of just adding our numerators together and then putting it over the common denominator. But what happens if you have two rational expressions that you need to add or subtract that have different denominators? Let's take a look. So for this problem, we're asked to add x plus 7 over 2x plus 12 and 6 over x squared minus 36. So the first thing you'll notice is that the denominators are different. So we need to go through a few more steps than we did in the previous two problems. Our first step in order to add these two rational expressions is to factor our denominators in order to find the lowest common denominator. That's the only way we're going to be able to combine these two expressions to get our answer. So factoring these gives x plus 7 over 2x plus 12 factors to 2 times x plus 6. We've divided out this 2, and that leaves us with this denominator. Now our second expression, 6 over x squared minus 36, this denominator factors to x plus 6 times x minus 6. So we can look at the factors here in both denominators in order to find our lowest common denominator, which includes the factors that are present in both denominators. So our LCD for these two expressions is 2 times x plus 6 times x minus 6. Because we have 2 times x plus 6 in this first expression, so all it's missing is our x minus 6. And in our second expression, we have x plus 6 times x minus 6, so all it's missing is the 2. So moving on to our second step, we need to change these two rational expressions into equivalent expressions that use the LCD that we just found. So in order to do that, let's start with our first expression. We have x plus 7 over 2 times x plus 6. So as I just mentioned, the only factor in this denominator that's missing in order to make it our LCD is x minus 6. So we need to multiply the numerator and the denominator by this missing factor. doing that gives x plus 7 times x minus 6 all over. Now we have our lowest common denominator, 2 times x plus 6 times x minus 6. So here's our equivalent expression. This is for our very first expression here. Now for our second expression, we have 6 over, we've got x plus 6 times x minus 6. So here, the only factor that's missing that will make our LCD is the 2. So we multiply our numerator and our denominator by 2. That gives 12 over our lowest common denominator, which is 2 times x plus 6 times x minus 6. Oh, I forgot to close the parentheses. Okay, so now we have our equivalent fraction for our first expression and our equivalent fraction for our second expression. We're going to use these two equivalent fractions here, and we're going to add these together. And that's going to be our third step. Now when we add them together, all we need to do is add our numerators together and put them over the common denominator. So I'll rewrite these up here. X plus 7 times x minus 6. That's over our common denominator of 2 times x plus 6 times x minus 6. And then we're adding our second equivalent fraction, which is 12 over our common denominator, 2 times x plus 6 times x minus 6. So again, we're going to add our numerators here and put them over our common denominator. And this gives, I'm going to write it all the way down here. We have x plus 7 times x minus 6 plus 12. And that's all over our LCD. 2 times x plus 6 times x minus 6. So now we just need to reduce this fraction in order to get our final answer. So we can't just add the 12 into this product here. We should actually multiply this out in order to add in this whole number. So let's go ahead and do that. Here, so this is going to be equal to, when we reduce, we have x times x, which is x squared, then x times negative 6, which is negative 6x. Working inside, 7 times x is 7x, and 7 times negative 6 is negative 42. And then we can't forget to add our 12. So this is still all over our LCD, 2 times x plus 6 times x minus 6. Now we just simplify this numerator here. So this is equal to x squared. Negative 6x plus positive 6x gives positive x. And then negative 42 plus positive 12 gives negative 30. Still over our common denominator of 2 times x plus 6 times x minus 6. We're almost done. Okay, so if we were to factor this polynomial at the top here, we would get x plus 6 times x minus 5. Again, that's all over our LCD. And then now we just divide out our common factors here. So we can divide out x plus 6, and we're left with our final answer of x minus 5 over 2 times x minus 6. So there you go. As you can see, working with rational expressions that have different denominators, if you're going to add or subtract, it's going to be a bit more of an in-depth process than if you have the same denominator. So we're going to work through one more problem that involves complex fractions. For our final problem, I'll walk you through simplifying a complex fraction. Now for review, a complex fraction in this section is going to include fractions or rational expressions in both the numerator and the denominator of the complex fraction. Now the trick to simplifying this type of complex fraction is finding the LCD, the lowest common denominator, of all of the fractions that are included in the total expression. So here if we look, our denominators in both the top and the bottom have either an x or a y. So simply our LCD is x, y. Now in order to simplify this expression, we multiply both the numerator and the denominator by our LCD. So we have 1 over x plus 2 over y multiplied by x, y, our LCD. That's all over 2 over x plus 1 over y, also multiplied by our LCD. So now we just distribute this expression over each term within the parentheses of our numerator and our denominator, simplify, and we'll find our answer. So let's start in the top. We're going to distribute the xy here and the xy to our second term as well. So this is going to be equal to xy over x plus 2xy over y. Now this is just the top part of our complex fraction. We distribute the xy over the first and the second term in the parentheses here, and we have 2xy over x plus xy over y. Now let's simplify both the top and the bottom, and we do that by dividing out our common factors here in each fraction. So we divide out our x here, and we can divide out our y here. And this then is equal to y plus 2x in the top part. In the denominator, we divide out our x here and divide out our y, and that's left 2y plus x. So here's our answer for simplifying this complex fraction using an LCD.